So this lesson is very much algebra. So stick with me and you should be okay. We're just going to be solving equations, solving exponential equations. So the first thing I want you to do is just think about mentally, how could we solve these? So if you have your square card, pause the video and find your square card because it's going to help a lot in this lesson. And in fact, in this whole rest of the unit, it will help a lot. Okay, so if you think about when you're solving equations, you want to make each side equal the other side. So I can see I need x to be equal to 2 because 3 to the second power equals 9. So I'm trying to make the left side equal the right side. So think about the second equation. What would make the left side equal the right side? What number makes the exponent on this side 5? So 3 plus 2 makes 5. So x has to be 3. This x has to be a 3 for the equations to be equal. So one of the things I just want you to think about, if the bases are the same, the bases are already equal to each other, the goal then is to make the exponents equal each other. And that's kind of the big idea for today. So we just have 6 examples, and every example we're going to focus on the first method to solving exponential equations. We're going to match the bases. So if we can get the bases to be the same, then we just need to get the exponents to be the same. All right, so in number 1, it's pretty spelled out. The base on the left is 2, the base on the right is 2, so the bases are equal. We now just need to get the exponents equal to each other for the equation to be true. So I just now am left with a linear equation. Subtract 1 from both sides, divide by 7, x equals 4. So when x is 4, I get 7 times 4 is 28 plus 1 makes 29. So when x is 4, the left side equals the right side. Now, number 2, if you're looking at your card, this is where it's going to be helpful. This side, the base is 3, and I can't break 3 down anymore, so I need to replace 81 with a power of 3. So I'm just going to bring down the left side because there's nothing more I can do with it because it's already base 3. I need to replace 81 with 3 to a power. 3 to what power is 81? 3 to the 4th power is 81. Once the bases match, set the exponents equal. So we match step 1, match the bases. Step 2, set exponents equal to each other. 2n plus 1. And third step, solve the equation. So get n by itself, subtract 1 from both sides, divide by 2, n equals 3/2. All right, number 3 is a little bit trickier because I need to break down both the base of 4 and the base of 8. So you need to create them into the same base. If you're looking at your card, look at what row both 4 and 8 are in. 4 can be broken into 2 to the second power. Then I leave 3x on the outside exponent. Bring down your equal sign. I now replace 8 with 2 to the third power so that my bases match. So both the bases have to have an equivalency here, and then they have to match together. Then always keep the outside exponent. All right, so this is a little bit trickier. First of all, power to a power, we need to multiply. That's what we learned yesterday, one of your basic exponent rules. So I'm going to multiply 2 times 3x, which is 6x. So bring the base of 2 down, multiply your exponents to simplify. Bring the base of 2 down. We need to distribute when you multiply. Distribute the 3 times x, 3 times 1. Now my bases are matched. So now I'm going to set the exponents equal. Now I need to solve the equation. So now I need to combine my like terms. So I'm going to subtract 3x from both sides. 6x minus 3x is 3x. Divide by 3. X equals 1. All right. In number 4, there are actually 2 different bases that we could create here, but if we change them both into base 9, it's easiest. So 81 is 9 to the second power, keeping the outside exponent the same, equals. Now, I want you to remember before when we were graphing, do you remember what 2 to the negative 1 equals? If it has a negative exponent, I need to put it under 1. 3 to the negative 1 is 1 over 3. What is 9 to the negative 1? 1 over 9. So notice I have 1 over 9, but I could rewrite it, move it to the top, which means the exponent becomes negative. So anytime you have to move a base into the numerator, you need to make the exponent negative. Now my bases are matched, so now I need to distribute, multiply the exponents. 2 times x, 2 times 4, so distribute the 2, equals negative 1 times x. Now get my x's on the same side, so move over the 2x. I'm left with 8 equals, combine like terms, negative 3x, divide by negative 3, x equals negative 8/3. Last 2 problems. I need to convert both bases again. 9 and 27 can both be changed into base 3. 9 and 27 are both on the row of 3 because 3 to the second power is 9. Bring down the outside exponent of 2n minus 1. Replace 27 with 3 to the third, bringing down the outside exponent of n. Now we're going to distribute, multiply your power to a power. 2 times 2n is 4n. 2 times negative 1 minus 2 equals, multiply 3n. Move the 4n to be over with the 3n. Bring down the 2. 3 minus 4 is negative 1. Divide by negative 1. N is 2. All right, the last one has a couple tricky steps. The first thing I want you to notice, this is base 3, and I can make 27 into base 3. 1 over 3 to the third. So I have to keep 3 to the third in the denominator where the 27 is. Then I need to move the 3 to the third to the top, which means the exponent becomes negative when I move it. So I'm just going to bring this down, bring this side down, equals, bring this side down, because now I notice my bases are the same, so I can set my exponents equal to each other. Here's where the next tough part of this one is. X squared means I no longer have a linear equation like we did back here. If you have an x squared, this is a quadratic equation. Quadratic equations, you need to set equal to 0. That means I need to add 3 to both sides, but the 3 doesn't match anything over here. So I keep the x squared plus the 4x plus the 3 all separate. And I need this side to be equal to 0. As soon as I have my quadratic equation set equal to 0, we can factor. So factors of x squared, x and x, factors of 3 that add to get 4, plus 1, plus 3. Now, what makes x plus 1 equal 0? When x equals negative 1. What makes x plus 3 equal 0? When x equals negative 3. So everything on this page, you need to keep going until you find out what does the variable equal that makes the left side equal the right side.